My name is Femke, in case you missed the first part. I'm a colleague of Sean, also working at MetaMeta. And yeah, welcome to the third and final part of our online masterclass on managing the microclimates. And for this session, it won't be just me and Sean talking, but we have Rula joining us. She's working at IdiWatch, and she will also tell something. So that's very excited. So the agenda for this session will be focused on our pathway towards a microclimate decision tool and managing, monitoring and mapping the microclimates. Yeah, so as we saw from the very extensive toolkit in microclimate management practices, as Sean presented in the last session, there are a lot of ways of how the microclimate can be influenced and managed. And this is very beautiful infographic created by Madia that shows how several practices can actually be combined on the same site. So for example, we see here, we see shading by trees, we see mulches being used, we see the use of stones, that they increase the moisture and the dew, as we talked about. Yeah, so all these different practices can then actually be combined and this way create a hopefully more conducive microclimate. But then how do you know what is the best suitable practices for a specific site? So of course, not all practices are suitable for each and every site. And this is actually quite a complex process. Yeah, so so for certain landscapes, certain characteristics are required for practices to be implemented. So some examples are, for example, rainfall conditions. And an example of this is that the eyebrow basins that Sean talked about are not suited for rainfall conditions below 1400 millimeters of annual rainfall. Another example that should be taken into account is the slope of the land. So for example, the soil bonds that we talked about can only be placed on a maximum of a 20% slope. Yeah, whether or not mulching material is available. Otherwise, this cannot be implemented, of course. Same for the availability of stones. And then soil conditions are also important. So for example, the terracing that Sean talked about is not very suitable for sandy slopes or very stony soils. So these are all landscape characteristics to take into account before deciding which practices to implement. And yeah, in order to sort of guide people in selecting the right services, we think that an assessment tool can be very useful. And then such an assessment tool is best to be based on both the scientific knowledge, so from studies like we did, that really dive into the scientific research, but we also think that local expert knowledge is very important to take into account, as Sean was, for example, talking about the focus groups and the interviews that we conducted in Ethiopia, to really for each region look at the local circumstances and really take the local expert knowledge into account when creating such an assessment tool. So an example of how such a tool then can work for agriculture is listed here. And no worries, I know that this is super small. I will zoom in later on, but this is more to show the aspects of which such a decision tree then consists. So we think it's really important that a decision tree first and foremost consists of a problem definition. So before changing or wanting to improve the microclimate, it's important to know what is wrong with the microclimate or where it needs improvement. Then the second aspect is what I talked about before, that it's required to find the best suitable intervention based on landscape characteristics. So for example, you cannot recommend doing terracing when the slope is super stony or when there's too much sand. That will do more harm than good. And then we also think that such a tool yeah, should provide some extra information about the microclimatic response to really enhance this, yeah, this learning cycle on microclimate management. So here's the zoom in on one aspect of the tool on soil temperature. So in the green boxes, first the problem is determined. And here we use several indicators. So this is really focused on agriculture. You should mention that as well, because of course microclimate can also be managed outside agriculture. But this is more to show like how such a tool then works. So the green really focuses on the problem determination. Then the several landscape characteristics are taken into account to advise a practice that is suitable for that specific site. And then such a tool ends with a sort of recommendation of how it then influences the microclimate to really, yeah, establish even more this concept of how, yeah, practices then not only, for example, increase the soil moisture, but how this really influences the microclimate. Then we'll move to monitoring and mapping the microclimates. And now I would like to give the floor to Rula. I think, Rula, you can share your screen. If I stop,
yeah. Oh wait. Yeah, just keep it a bit. So maybe.
Okay, Rula, I give the floor to you, and whenever you want to share your screen, just let me know. Then I will stop share mine, and then I think you're able to share yours then.
Yeah. Okay. Yeah. Maybe I will talk a few words about this, but because you triggered something with your introduction. First, I'm going to say hi to everyone, and I hope you're having a good course. Yeah, so now you have to listen to me. I just want to say something because I worked in conservation agriculture back 10 years ago. And we always said conservation agriculture can help you, like conserve moisture, save energy, save water, improve the biota of your plant so you can have more earthworms and so on. And I was preaching about this to the farmers in Lebanon. But then there are things that we were able to measure and show them. So we were able, for example, to measure soil moisture maybe and show them that, you had more moisture. Or maybe we were counting the earthworms. So we actually took a square and then count earthworms. We have more earthworms. Or how much saving you did because you plowed less or whatever. But then at some point it was like, okay, but then we tell them, yeah, you were able to do more carbon sequestration. But then I'm like, yeah, okay, how do you measure this? So there are things that sometimes it feels like, okay, but then how do we do it? And then comes the satellites. Okay, so remote sensing can do things, but it's always a challenge about mapping the microclimate with the satellites, because people say like, okay, satellites can see like big pixels or something. Maybe drones can see more or whatever. But then even if we have also the agro-ecosystem, the agroecology, the different layers and so on, there are still things we can see when we are talking about like a 10 meter by 10 meter pixel or something. And when I say see, it doesn't mean actually just the visual bands. When we talk about remote sensing, and the most important, at least for us at AreaWatch, is the thermal imagery. Okay, so this is the temperature, because this is the driver of everything. And just to give 2 words about AreaWatch, so we are a satellite-based irrigation advisory company, but not only irrigation advisory, but also we give information about crops and practices and so on. And the basis of our models is SEBAL. SEBAL stands for Surface Energy Balance Algorithm for Land Surfaces and Mapping. And probably if some of you know about it, you can Google it, you find a lot of papers about it, but it's based on the energy balance, which is what you see here in this picture. So it's all calculated in this energy balance. So we have radiation coming in. So this radiation coming in from the sun, this is what's driving the whole cycle of water from the soil to the plant to the atmosphere. And some of the energy goes to heating the atmosphere. Some of it goes to heating the ground. And what is left is what we call the latent heat flux, or what is commonly known as evapotranspiration. So this is what the plant transpire either through the leaves or evaporates through the soil surface. So this is the ET, evapotranspiration. And the whole energy balance, so it is calculated as a residual, because we can tell how much energy is coming in, how much is going to heat the ground, and how much is evaporating. And this equation, the ET equals radiation minus ground heat flux minus sensible heat flux, or what goes into heating the atmosphere. This is where the whole game comes into place, and is driven by the temperature as well as the crop characteristic. And here I just want to say that when we have plants, we have higher ET. Okay, so usually in this equation, when you have ET is high and then the sensible heat flux is low. But then when you have only soil, then you have the other way around. Okay, and this is when you hear sometimes like, yeah, if you have plants, then you can cool the environment, right? You can have a better microclimate around the plants because it's cooler when you plant, and we experience it. But now we can measure it. Okay, and I'm gonna stop here and maybe show, because I don't know how much time I have, maybe limited, but I'm gonna show something how we do it. So I just stop talking. I can actually show you what I mean. Okay, you guys see my screen? And you can all do this the same what I am doing at some point if you just go to the portal, and we have some free demos that are available. So we have these plots in Egypt, for example. So this is our portal. This is where our clients or people can see the data. And then here, what you can see, these are some plots in Egypt. For example, we have apricot, we have alfalfa. And then when I hover over the fields, you can see the name of the crop, the soil type, and then what is the irrigation system. Here is drip, here is pivot, and so on. And then we have several things. So you can always have history, the data, where you can see which day you want to see. Then we have things at the field level and pixel level. I'm just going to show you an example so you know what I mean. So for example, this is a vegetation cover index. So we can look for every pixel. So when I say every pixel, so if I zoom in, each one of these small square is 10 meter by 10 meters. So you could literally, so this is an apricot field, and then you could see the differences across the field and so on. And this is the vegetation cover in percentage. And you get this on daily basis for each 10 meter by 10 meter. Another maybe thing I want to say is probably we can get actual evapotranspiration. So for each part of the field, how much water is evaporating from the plant. And this is how you know how much you need to fill in. Okay, the same goes for soil moisture, because maybe this is more of importance to you. So how much soil moisture there is, then we can know if some parts, needs more attention, or there's a leak in a pipe, or there is something happening that you need to take care of. But not only irrigation advice, but also maybe I'm going to show crop production. Okay, so this is maybe cumulative crop production. So this is how much dry matter is being produced in the plots in kilogram per hectare. Okay, so this is cumulative. We also give it day by day. So this is related to production. How do we do this production? Because this is about the photosynthesis, right? So it's the carbon fluxes, the water fluxes. So we do kind of an integrated water, energy, heat, carbon modeling to get all these parameters. And then we can calculate how much crop production is happening. This is, again, maybe here I can show leaf nitrogen. So these in percentage of the leaf nitrogen you could see. Maybe one more, carbon supply into the soil. Okay, and maybe something important you just mentioned, Femke, which is maybe soil temperature. So this is given daily. So not the air temperature, this is the soil temperature, and it's given at for each pixel on daily basis. As well as the land surface temperature as well. It takes into account what's happening on the crop level. But this is for each pixel by each pixel. Sometimes it's more practical for farmers or decision makers to have it as an average of the whole field. That's why we provided what we call field level here, for example. So you can have this, for example, actual ET, and then it will show you in this one. Related maybe more to microclimate. For example, if we have rice fields, so for example, we do, let me see, what is it? Methane emissions. So methane for rice, we provide this for our rice producer. Maybe also, again, the carbon, where's the carbon? Somewhere. Maybe I'm going too fast, but I don't want to take too much time of your project. So this is the carbon supply. So how many kilograms of carbon per hectare per day are being supplied into the soil because of your growing crop. Okay, so this is something, but it's not only about the visual, so it's also about the data. So if I click, for example, okay, sorry. So if I click on this plot, so the first thing you get here is your soil moisture. So this is your permanent wilting point, your field capacity, and then the blue is your soil moisture, and you see how it's changing. So somehow this farmer is doing good things. Okay, well, that's fine. But then we can track, so it's a timeline. You can see it not only visual of the last day, but you can see the cumulative things. So this is, for example, the accumulated crop production. So this is the black is the vegetation cover. So we see here they had not planted, and then they planted, the crop started to grow, reached a peak, and then maybe harvest happened here. And then here you see the blue is the actual crop production, and then the orange is how much you could have achieved if you didn't stress your plants. So this is the potential that you could have had. And also we have something we call the attainable production. That is, in some cases, you have very good performing maybe areas of your field, and they have very high production. And this is something you need to follow. So you need to investigate more and what's happening there. Do we have more carbon? Do we have more, I don't know, nutrients? What's happening? And then you can do what needs to be done. Maybe leaf nitrogen. So this is, for example, a project where those guys, they started fertilizing beginning of the season, somewhere in end of May. And then you see the crop as it is growing, it's picking up the nitrogen, and then you could see it in the leaf that it was increasing. But then as the crop was getting more mature, they did not add any more nitrogen to so it started uptaking all the reserve of the soil, and then automatically it was decreasing as a percentage, and then the harvest was happening. So this is leaf nitrogen, for example. Maybe I will show one more, and then soil temperature data. Okay, let me turn this one off and maybe trigger some questions. Here we are seeing the soil temperature and also the air temperature. So in some case, so the blue is the soil temperature. So we see here, for example, the soil temperature is higher than the air temperature. But then later on, it's lower than the air temperature. Any idea why could this happen? Anyone would want to maybe type in the chat or say something? Okay, maybe not. Or maybe I'm not hearing if anyone is saying something. Okay, well, I will say, okay. Okay, so here what we have is that the crop did not grow yet, so the soil is exposed. Okay, so this is why it's just getting all this radiation, it's getting all this heating, and this temperature of the soil is even higher than the air temperature. But then as the crop was growing more after end of May, then we see that the soil temperature, because the soil is now more covered, so it is getting maybe more shade, and also the crop is doing some cooling. And this is why the temperature of the soil is getting less than the air temperature. So this is an example of how you could see it. We also have something that here may be interesting, what we call the mid-air cooling, so midday air cooling. So this is actually quantifying how much cooling you are doing into a, let's say, depending on whatever the crop is. Let me take maybe some apricot tree fields. And this is related to how much, when you have all these trees growing and doing this evapotranspiration and being irrigated and so on, so they are creating a microenvironment around this, or microclimate around these plants, and this is contributing to the cooling of the air. And here we can measure it. So here we can see it varies somewhere maybe between 4 and 10 degrees, the cooling of the 2 meter above the crop. So this goes back to the assessment tools maybe, or what Femke was talking about, or maybe the question of what is suitable, what is not. Okay, and here it is, we can measure it. Okay, so we can see if we are doing different practices, maybe we can have some indicators about what worked, what did not work, and then how, how to evaluate. So in addition to all these other assessments that you have to do, but also you can make it more of a measurable indicators of the success of a certain system and so on. I'm gonna stop here. I hope I was not maybe too quick, but yeah. And well, I don't know if somebody wants to ask anything. I can see questions maybe in the chat. Let me see. Yeah, free subscription. Yeah, it's free for the demo. You can see it. You can check what it is. But then it's a paid service. There's always a 2 weeks trial that you can try it. You can sign up fields, and all we need for this is just a plot that is, or a combination of different plots with a total of up to minimum 25 hectares, usually what we say. But then, and then you can sign it up, you can try it, and then you can see what data you can have. But then I would advise you, if you think this is something interesting, to look for the demo, check what it is, it's active, and then you can see it somewhere else. But, yeah. Anything else I should take a look at? Okay, any other questions, comments? No, okay.
Yes.
I think you are tired, maybe. It's the third session. Yes, go ahead, Miriam.
Yeah, I had a question. What data do you use to generate these maps?
Yes. Okay. So what we do is we use a combination of different satellites, because, as you know, so this is satellite based, right? And then we say 10 by 10 meter pixels. So this is based. The 10 meter by 10 meter is based on Sentinel, but we also do Landsat 7 and 8. And then we use also other satellites like EcoStress, VIRS, Meteosat, and all these data. And then not always we have a screenshot, because you have sometimes clouds, okay? And then you have the rotation, the cycle of the satellite. So sometimes you have maybe 2-3 days without, but with the combination of the 7 satellites we use, we have almost coverage. Some are of different resolution, but then we downscale based on the vegetation and other indicators. But some parameters which are more important for us. So the land surface temperature, for example, we measure every day. The radiation we measure every 15 minutes. And the temperature and the radiation, these are two essential, and the rainfall also. So these are essential parameters that helps us, the calculating the whole energy balance. And in any case, we always have in the background, we run a water balance model. So for the days we don't have a satellite image, we have a water balance in the background that can predict what's happening. And then, but then, for example, the vegetation cover will be updated when you have another satellite image. I hope I answered. I don't know if you have.
Yes, thank you.
Okay. Any other questions? How the app will generate timely data. So every day at your breakfast, you will have the update of what happened in your field, or what's the status of your field. So in the morning, because so we take the picture is usually taken around midday. But then to collect all the data and what's happening throughout the day, the radiation and so on. So we provide the data around midnight. So in the morning you can have it, and then you can see what's the status of your soil moisture, for example, of the other parameters, and then you can make decision like, okay, do I need to irrigate? Do I not need to irrigate, and so on. But then some decision you need to take at the different levels. If it's not irrigation related, sometimes it's like, do I harvest or not? Like, did I attain the maximum production or not? Or do I do a final irrigation or not? And this is sometimes you take the cumulative application. Okay, Khalid is asking, did you confirm the obtained data with this tool with real quantification of elements such as nitrogen, etc.? Oh, okay. So for the nitrogen, this is where, well, we always, just to say, we always do validation with our clients, just for us to, from one side, to also do kind of assessment and improvement, so to always get feedback from the clients and so on. But we also do validation for the farmers themselves and the clients to make sure this is happening. For example, now we have a project in Egypt with the farmers, and they actually do go measure themselves the moisture, for example, or the leaf nitrogen. They take sample, they analyze it in the lab, and so on. But so, and as I said, that's why I mentioned at the beginning, you can Google Sabal maybe or something. But just to say about the nitrogen, it's more of the commonly known models about it's not something we developed specifically, but then because we have the NDVI or the NDRI, so it's like more the red edge and so on. So so this is okay. I'm just reading why I'm answering. So the red edge are used usually to quantify the nitrogen, and it's not something we developed. It's just what's available. Brit is asking, can we have historical data? Definitely, we can go back in time as far as, I don't know how many, 5 years, 10 years you want to go back, because this is satellite data. So we can back calculate and then go back in time and have the data. And sometimes we run the data on, for example, monthly basis, because you need the daily data because you want the daily data for decision making. But then if you are looking at historical, so for example, let's say now you have a plot where you started doing a new practice, okay? But then you don't know what was happening or what was the state zero, if I want to say. So we can go back in history, and I think we're going to do something similar with John for some of the plots. So we have let's say from last year, what was the situation, and now we started doing this practice. Then we can say measure what's happening now. What is the maximum temporal resolution of this app? So this is, as I mentioned, I don't know, I think maybe you missed my answer, but we do provide daily data. But as I said, because it's a combination of satellites, you sometimes have days without an image of a visual and update of the green cover and so on. But then for the calculations, we are using different things. So we always have daily, well, assuming no clouds also. Even if you have clouds, and we always have daily, as I said, we have daily land surface temperature, and then we always have daily radiation, rainfall, but then we do also run a water balance in the background to do this. Is operational.
Or maybe is that daily data for all area in the world? Maybe if I miss, sorry, that you provide just daily data for all area in any place.
Any place if you have cloud cover less than 50%, yeah. I mean, otherwise it's just going to be compromised, right? I mean, we can give you the data, but then if you have 2 months with no satellite imagery because you are in, I don't know, Ghana, then you're not going to miss it. You know what I mean? So it will just be any water balance model. Then you don't really benefit from the satellite. You can provide the data, but it's not based on, you know what I mean? Like, because we are talking, so usually when we have clients coming from areas where it's really cloudy, then we say like, sorry, you know, like you don't have to pay for something you're not going to really benefit from. Okay. Is it operational or forecast model or assessment model? How do you assess water supply parameter? Okay. Okay, interesting. Yeah, it's more of an operational and forecast. Okay, so let me see. Let me try to explain it. So we assess the situation because we are measuring. So as again, I said, go back, step back, which is going back to the energy balance model. So we are measuring the fluxes. Okay, so the fluxes is the photosynthesis, the opening and closing of the stomate, how the water is, the energy is getting out this water and so on. So this is driving the whole soil water potential. So what I calculate first is the soil water potential, and I convert it based on the soil type. So one of the inputs that the farmer should give me or the client is the soil type, because I cannot know the soil type. I can tell from the soil grids, but we all know the uncertainty of these soil grids. So it's always good to have a local soil analysis. Then based on this soil, I know how much, because I have the soil water potential, I convert it to soil moisture, and then I can tell how much millimeter there is in this soil. And I do forecast for the next 5 days based on the weather data. So we know how much potentially, you know, like how many days, for example, until next irrigation and so on. And we updated later on, okay? To assess the water supply. So sometimes you could see in the soil water and soil moisture. So we see an increase in the soil moisture, and this soil moisture increase, it could be coming either from I don't know, rainfall, but then if there is no rainfall, there could be coming from irrigation. So again, it's about the water balance in this. What about validation of this app? Do you measure accuracy? Yes, I did mention this before. I should share with you our validation book. We're having one upcoming soon. Yes, we always do validation. It's not just this app. It's not something new. Sebal was developed in 1998. Okay, so the model, I mean, we keep improving. So from 1998 till now, it did improve a lot. But then, so Wim Bastiansen developed this model back in 1998. And it's actually many of it is actually public and open source codes. You can find it. You can Google Sebal. You can find open source for this, but maybe they don't have the updates and the user friendly, like whatever. But it's there. The concepts are there. The equations are there. So people have done the validation. There are more than 20,000 citations for Sebal all over the world. So people have done the validation for us. Thank you. but also we continuously do it with our clients to make sure, we are also always...
I want to ask just the area watch specifically, maybe the accuracy of this area watch.
Yeah. Well, this is what I'm saying. AreaWatch is based on the Sebal model. So this is the Sebal 4.0, let's say. It was 3, what's public, but then so yeah, this is what I'm saying about this AreaWatch app. That's why I'm saying the validation book. You can go to LinkedIn, to our AreaWatch on LinkedIn, and then there should be there somewhere a validation book, or I can also share it with you, no problem. Then you can see exactly. I mean, okay, wait. Can I share again my screen, Jean? Do I have, or Femke, a couple more minutes? Okay. I'm gonna just, because maybe this seems to be a bit interesting. Let's hope I have, yeah, okay. You guys see my screen again, right? Yeah, I'm just gonna, okay, so let me maybe show. So this is a bit about the fluxes, like how we calculate everything about, so this is a leaf, okay? So this is the stomate of the plant, if you know what it is. Then you have the energy going in for the light interception, all the photosynthesis, what's happening, and it's about energy, carbon, and water balance. This is where we are active now in the world. So these are our clients now operating, reading every day this data. Maybe what I wanted to show is something. This is, for example, one example from a potato farmer in the UK that was using last year. So we did this test last year with them. So what we did is we had, so in their harvester, they have a yield sensor. So this is a gourmet harvester. It has a yield sensor on it. So when we map, so this is our yield prediction, how much it was, and we calculated the expected ton, and then we, we do it with them. So we have kind of like these kind of validations. It's always happening with our clients. So we get data. We have soil moisture. I don't have graphs here. Sorry, I opened the wrong presentation. But yeah, we also do validation with soil moisture sensors and other things. Yeah, what about validation? Okay, now I answered this question. Guess I answered all. Any other ones? Next one. Historical data, we said yes. Okay.
Yeah, thank you so much, Rula. It was super interesting to hear about your expertise. Yeah, and I'm also really happy that there are so many questions and interest in the AreaWatch model and Sebal in particular. Yeah, really cool.
Yeah, I hope maybe somehow it can help monitoring and mapping this microclimate. So
yeah, we'll also end with an example of how AreaWatch and this project in Ethiopia will be collaborating. So maybe everyone's.
It's also a dear country to myself, because I worked 3 years in Ethiopia, so I always feel special to be part of this. Yeah,
I can imagine.
Yeah.
Okay, I will share my screen again.
Mm-hmm.
And then we'll move to the last part of this presentation. So we'll shortly talk about this whole microclimate project and where we're heading and what's on our agenda. So currently we're very busy really establishing this concept of microclimate management. So we're writing a reference book in case someone is interested. We can of course share it with you. We're developing the tool that I showed before, and then of course this webinar is also part of establishing this concept. So we really hope this all helps developing this concept further. And then in the future, of course, we want to improve the prototype tool, gather field data together with AreaWatch, also through microclimate sensors, but also remote sensing as AreaWatch is doing. And this will really contribute to validate the tool. Yeah, and then once this tool is optimized and validated, of course, implementing it wherever possible. Yeah, so we're also going to work together with IRIWatch in Ethiopia, as I shortly mentioned. Maybe Sean wants to tell a bit more about this project that is happening soon. I will mute myself then.
Yeah, hello again, everyone. Yeah, so I'm just going to give a little example of the work we're doing at MetaMeta, also in collaboration with IRIWatch related to microclimate. So it's part of the project that we're working on in Ethiopia. It's called the Green Future Farming Project. We're working towards establishing some community managed farms in a plot of land that's not currently being used. So we're looking at about 30 hectares here, and this land will be brought under regenerative agriculture practices with mixed cropping and yeah, many of the microclimate management practices that we mentioned earlier. So this is really a fantastic test site for us where we can put into practice all the research and all the conceptualization that we've been doing on microclimate. So the idea here is that we'll have some monitoring done by IRIWatch so that we can really look at these variables from the satellite images, but also do some ground validation with some microsensors and working together with the communities and the extension workers in this area just to gather as much data as possible. And I mean, on the one hand, it's acting to verify and validate the data that's coming from IRIWatch, but also from our side, it's building up capacity for farmers to be able to monitor their own conditions on the field. So I'm really excited about this aspect of the project. Can we go to the next slide? Yeah, so some of the stuff that we'll be looking at in this plot is the crop production in terms of dry matter, so that's the biomass. Cumulative, just like Rula was showing us earlier, soil moisture in the root zone, sequestration of atmospheric carbon, changes in soil organic matter content, temperature and humidity, and cooling of the air and soil temperature due to the cropping. Yeah, so these are the main parameters that we'll be measuring, but also we're exploring the possibilities of what sensors we can get into the field over there and which parameters we can really measure and plug those all into a system and just see how everything's interacting and just prove really that, you know, microclimate is a way of empowering farmers to take control of the climate in their area. I mean, climate change, as we said in the beginning, is affecting all of us, and it really does have a way of making us feel a bit powerless because it's just all happening around us, and what can I do to change the climate? Well, you can definitely do something to change the microclimate, and we're hoping that from this pilot site we can really demonstrate that and put a little bit more power in the hands of farmers. Yeah, Francesco, I see a question from you about mixed cropping. Yeah, we, through some work from our colleagues at MetaMeta, we've prepared some plans of potential intercrops that could work in the area. And I was talking to IRIWatch about how we can monitor this. And what you can do is you can actually, well, after you provide the main plot, you can create smaller polygons within there and they will be analyzed separately, if I understood that correctly. So the more polygons you put in the big plot, then the more data and the more subsets of data you have available to analyze. Rula can correct me if I'm wrong about that, but I think that's basically the concept. So you just mark the individual rows, state what crop they are, give them the soil type and everything, and they're able then to give you specific details about how that crop is doing.
Yes, because
so this is one of the exciting next steps we're taking together, and the results of this microclimate monitoring will eventually make it onto the water channel, and hopefully this is one step closer to really understanding how we can manage the microclimate. Yeah, I think I'm done from my side. Femke, I'll go on mute.
Yeah, so maybe before we end, we can all have a final end discussion. Maybe if you have any thoughts resulting from our presentations, please unmute yourself, take the floor, or in the chat, of course, that's also fine.
Yes, It's again me, Francesco from Spain here. Yeah, sorry, I talked too much maybe. No, it was very great to see the ERIWatch platform. I was very keen to see how it looks like, how it works. It looks amazing. And I was trying to relate that to my small farm that is a sub-hectare intensively under production with more than 10 different kind of vegetables. And yeah, so I was thinking that, maybe correct me when wrong, but every other meter you have a different crop. So I'm thinking that in some situation is also maybe important to have some tools that the farmer directly can measure himself or herself. Like, I don't know, it could be thermometers, but it could be also some, let's say, more qualitative indicators, like experiment with plants, putting them in different position, and after a couple of months measure the stem length, the fruiting, and the flowering stage. Just some thought on the micro scale. So I'm curious also because you mentioned microclimate sensors and what you meant with that.
Yeah. I don't know. Can you hear me if I speak like this?
I do.
Okay. Yeah. So, oh, hi. So with the micro sensors, there's another organization that we're talking to right now that should be able to help us actually build some sensors that can look at temperature at different vertical layers where the crop is growing. So really at the soil surface, just beneath the soil, you know, maybe 1 meter high. And the idea is to do capacity building with the farmers to be able to use these sensors. Of course, a lot of other parameters are quite easy to measure, like wind speed and direction, for example. This is still a work in progress. It's something we hope to roll out, you know, towards the end of this year. So I like your ideas, and we can talk about this a bit more because, yeah, like you mentioned, there's a lot that goes into this. So it's one thing to measure these microclimatic variables, but then we'd really like to see how they're influencing the different crops as well, because we might have a preconception of what the ideal microclimate is for this crop, but then the crop might be telling us a different story. So yeah, it would be very interesting to also measure these variables. Mm-hmm.
Nice, thanks.
Yeah. Maybe Miriam, Martin?
Yeah. Thanks for the presentations. It's been really interesting and inspiring. The question, or it's more food for thought, I suppose, which is, judging from what I've seen, a lot of the interventions that deal with the microclimate are sort of program driven, and the monitoring is satellite driven. And as part of the GFF program, I think maybe some of the next steps, or well, of course, the concept is just being developed, but it's something to think about. Is what could be the drivers for small-scale farmers or subsistence farmers to take up these measures independently. So moving away a bit from project logic that says, you have a problem with your microclimate, we have just the thing for you, allow us, we'll put A, B, C, D, and then finish. So more or less the same. Yeah, look at the same kind of social, economic incentives that would allow you to reach more scale rather than have a simple implementation logic just for the project itself. I don't have any answers. It's just I'm still coming to terms with the whole with the conceptual work. But I think I'd be very interested to either hear experiences or share ideas or have discussion about not implementing it directly, but looking at these ways so that farmers can work it out themselves somehow.
Yeah, I mean, I'll just come here. That's okay. Hi. Yeah, I 100% agree with you, Martin. I mean, at this point, like you pointed out, we're really still at the conceptual stage, but it would be fantastic to down the line see, you know, farmers or people who have a landscape that they're managing, just taking these things up of their own initiative. How to do that? I would also love to hear anyone who's got experience with this and share some ideas, but I'm just thinking about a couple of the examples that we were giving throughout the presentations, like for example, what's happening on Lanzarote, what's happening on the Azores. Now that really was farmers just adapting to the situation and building their own eyebrow terraces and, you know, building their own windbreaks, and it arose there out of necessity. Now, hopefully, I mean, in the areas that we're working, we can avoid people resorting to things out of necessity, and hopefully people start to do things before it gets to that point. But how to demonstrate to people and how to encourage them to really take this microclimate issue into their own hands, it's something I think we need to work on and really, really think about.
Yeah, still maybe as a small addition to that, because the challenge that that you find in many areas, and also for instance, in Ethiopia where we're working, it's the whole social political situation whereby you have a lot of overgrazing that is creating a worsening of the climate, the microclimate, I suppose. So. There, a simple implementation of a technology wouldn't work like it does to work in many of the for instance, the Sahel countries with the regreening. Well, it's all a good idea if you are able to control so many external parameters. Don't want to be a spoil sport and say, this is not going to work. I think it has, you know, it has to work. It's just thinking about the ways to get there is, I think the next challenge.
Yeah, 100% agreed. In fact, at this point, I'd like to open it up to anyone else who maybe has experience with this kind of work or has a story they can share from the field or from their own experience.
Yes, maybe I can add something there again, Jean. So linking to what Martin is saying, I think I can relate to that because this summer in Spain, we had like some weeks of 40+ degrees. So it's always hot there, but this summer we had a couple of weeks that were a bit of outliers. And then tomatoes start to get burnt. So instead of red, you have these yellow, wrinkly patches on the tomatoes. Mm-hmm. So we started to do all we could actually to protect it. And then actually I was talking with Jean and Femke quite a bit about this whole microclimatic story. So I'm a bit of a spoiled kid here, but I tried to change the shading and also change the moisture level in the soil. So, and in the end, we got some shade nets and hanged it on top of the tomatoes, and it helped quite a bit. So I think the story of the necessity, I think I relate to it very much. And the similar we did with lettuces with some other sort of shading, and that I copied from another farmer nearby that found this way of adapting some kind of nets to shade the lettuce. So I think that out of the necessity and seeing examples and seeing that is possible probably, because lettuce in the middle of the high plateau in Spain is usually not possible in summer, but then you see somebody that does it and then you visit the farm and you try to do the same. And I have to say it was not too successful. I think I had to change a bit more the watering there, but I think get in there.
Oh, nice. So that's a really practical example then, where yes, necessity does drive innovation, but also demonstration. So like you said, you saw a farmer nearby who was trying something out, and you gave it a try yourself. And I mean, Martin, through our project, I'm hoping that this is the kind of effect we can have, where if we do demonstrate that, look, this is not only improving your yields, but also improving the microclimate in general, making it a more pleasant and a more sheltered place to be. hopefully that will have enough of an impact that people will see that and say, yeah, I want that too, and take their own initiative. But yeah, of course, there's a lot of other socioeconomic factors like availability of capital and a lot of other things we need to take into consideration. So I think we can just do our best from our parts, and also learn from our experiences as we go along. But yeah, we'll see.
We have time.
Maybe you want to add something?
Yeah, maybe if there's anyone else who wants to take the floor. Otherwise, it's also time to be wrapping it up. But yeah, I'm really happy to also hear about Francesco's example that when the necessity is high, for example, the 40 degrees in Spain, that made you adapt to that climate and improve it for your plants. I think that's very inspiring. And what Sean said, I hope that by having this first plot in Ethiopia and putting these practices out there, maybe you can have a ripple effect and really raise the awareness amongst farmers to really show that you can actually improve your climate in light of global climate change. And I think that's something, it's a really hopeful narrative, I think. Instead of like these daunting messages that we hear every day about global temperature rise from 1.5 to 2 degrees, which we feel like we can do nothing about. And then there's this alternative narrative of microclimate management that, as Sean said, that really gives everyone tools in their near environment to change this and to improve their local environment. So I think this more positive way of looking at this problem, and then together with this hopefully this ripple effect that the demonstration sites will have, maybe this will forward the microclimate agenda. It's also time, so maybe for one less person to step in, and otherwise we want to thank you very much for participating.
Hi Femke, and hi everybody.
Hi.
I think there's a lot mentioned, and it's good to keep all of it on the one website, a separate website, to also place an open section, people who have the experiences like Francesco and other people explained what kind of lesson they learned with the microclimate experiments, so they can also share it, and we will learn more about it from different parts of the world. So I think maybe next step to have a website for the microclimate.
Yeah, that's a really good suggestion. Yeah.
I mean, we've already brought a lot of this content together in the book. Yeah. Which hopefully will be, when's that happening, Femke?
We will hear back from the publisher in 2 weeks. So I think, this fall we will publish the book. And that will contain a lot more examples that we showed here. Not only theoretical, but also like things that are really happening in the field.
Mm-hmm.
Yeah.
Yeah, but I like your idea, Sukru. In terms of outreach, it would be good to get this online.
Yeah.
And start creating a bit of maybe a community of practice around
it.
it.
Yeah, for sure. Then Moti is asking if there possibility to share the presentation. I can share the slides with anyone interested, but the whole presentation will also be on the Water channel. I think as soon as possible after we closed up.
Yeah. Thanks for the positive feedback, Greta. It's good to have you here.
Thank you. Yeah, and in case if any questions, requests, or feedback raises after this presentation, you can always send us an email. Our emails are also on the MetaMeta website. And we like to stay in touch with everyone, of course.
Yeah, thanks for joining, everyone.
Yeah,
and we will send an email around once everything gets uploaded onto the Water channel. So there'll be quite a bit of information on there, plus the recording of all 3 sessions.
All right.
Yeah.
Thanks, everyone.
Thank you.
Have a good day.
Bye.